In number one, we have two functions, f and g, and we want to find some values of these composite functions. So first, let's look at f of g of 2. So we start with the inner g function, and we want to find g of 2. All right, so here's g. We're just substituting in 2. So we can maybe do this on the side. G of 2 is equal to, we're just going to substitute in a 2 right here. So if g of 2 is equal to 2 squared plus 1, that's 4 plus 1, so that's 5. All right, so f of g of 2 is f of 5. And now we're substituting 5 right here. So that's 5 times 5 minus 2. We put 5 in for x. Okay, so that's 25 subtract 2, and that's 23. All right, now let's form g of f of 4. So first we want to figure out f of 4. Let's just do that on the side over here. We're substituting in 4 right here for x. So that would be 5 times 4 minus 2. Subtract 2, so that's 18. So f of 4 is 18, so we're looking at g of 18. All right, here's g, so we're going to substitute 18 right here. So we have 18 squared plus 1. That's 18 squared is 324 plus 1, and that's 325. Okay. All right, next we're looking at f of 1. So first we want to figure out f of 1. Let's do that on the side. Here's f. We'll put a 1 right here for x. That's 5 times 1 minus 2. All right, that's 5 minus 2. So f of 1 is 3. So we want to put the 3 right here. So we want to figure out now what f of 3 is. Just substitute a 3 right here. We have 5 times 3 minus 2. 15 subtract 2. And that's 13. In number 2, we want to form these two composite functions. So let's start with f of g of x. G of x is equal to 2 minus 3x, so we're going to put that right there. Here's our f function. Instead of x, we're going to put g of x. And right here we're going to replace g of x with what it's equal to, 2 minus 3x. All right, so let's do that. So in parentheses we have 2 minus 3x plus 1 squared. Let's just combine these like terms. So we have 3 minus 3x squared, and we can just leave it like this, or if this is, let's suppose this were a multiple choice question, then maybe the solution would be squared out. So let's square this out. We're multiplying out 3 minus 3x times 3 minus 3x. Let's do that. All right, so we have first times first is 9, and then here we have minus 9x and minus 9x, that's minus 18x, and here we have minus 3x times minus 3x is plus 9x squared. In number 3, we just want to complete this sentence. A function is one-to-one when every x every x corresponds to one y, and every y corresponds to one x. All right, this is the basic picture that we have in mind. So let me just write it out. Every x corresponds to one y, and every y corresponds to one x. The horizontal line test determines if a function is one-to-one. All right, here I'm just going to draw a little picture of a function that's one-to-one. Let's say something like this. Okay, so that's a picture of something that's one-to-one. Let's say this is y equals 3. If we draw a horizontal line, we see that there's only one y value, only one x value right here. Only one x value that corresponds to 3, y equals 3. All right, and let's say whatever you choose, any y value that you choose, let's say this is 4. There's only going to be one x value. Let's call this one x sub 3 because it corresponds to 3, and maybe we'll call this one x sub 4 because it corresponds to 4, but we only have one x value corresponding to 3 and only one x value corresponding to 4. All right, this horizontal lines hit the graph only once. So this is an example of a function that's one-to-one. All right, let's look at another one that is not one-to-one. Something like this. So let's say this is 3 over here. And here's a horizontal line. Let me have this dip down a little lower. All right, so this horizontal line crosses the graph 3 times. So here, y value 3 is going to correspond to this x value, this x value, and this x value, 3 different x values. So we have 3 x's for one y. Now let me mention that if f is one-to-one, then it has an inverse. Okay. So in this problem number 5, it says assume f of x is one-to-one, so then we can talk about f inverse over here. All right, so it says assume f of x is one-to-one and f of 2 is equal to 7, then what's f inverse of 7? Well, let's just draw this little picture. We can say that f takes 2 to 7. That's what we mean by f of 2 is equal to 7. 2 corresponds to 7 under f. And f inverse will do the opposite. So f inverse takes 7 to 2. So here, f inverse of 7, we can answer that first question. F inverse of 7 must be equal to 2. All right, let's look at this one. F of f inverse of 7. Well, we already said that f inverse of 7 is 2. So what we're looking at here is f of 2. And we have that f of 2 is equal to 7. Even if we didn't know that f of 2 were equal to 7, we could do this. Let's say we want to figure out what f of f inverse of 3 was. Well, f and f inverse, they undo one another, and we get back to the value that we started with. So we could just put 3 here. All right, even if we didn't know what f inverse of 3 was, by the meaning of a function and its inverse. If you do the inverse and then the function, you're back where you started. Or the opposite way also, if you do, let's say, the function, you get some value, and then take that value and plug it into the inverse. Again, you're back where you started. In number 6, we want to find the inverse of this function. So here's the procedure. First, you replace f of x with y, so we'll no longer use function notation. Okay, next what we're going to do is switch x and y. And finally, just solve for y. Okay, so I'm going to subtract 7 from both sides. And now I'm just going to divide by 3. And now I'm going to go back to function notation and call this f inverse of x. Let's do a little check over here. Let's show that f inverse of f of x is equal to x. Okay, so f of x, remember I have it up here, it's 3x plus 7. So we're going to put 3x plus 7 into here, into f inverse. So we're looking at f inverse of 3x plus 7. Here's f inverse. I'm just going to put parentheses instead of this x. And I'm going to put 3x plus 7 right here instead of x. So now if we open parentheses, we have 3x plus 7 minus 7 over 3. Okay, these 7's cancel. And we have 3x over 3, so we do get our original x back. All right, and that's half of the check. The other half would put the f on the outside and the f inverse on the inside and show that we get x. So our check consists of this, this demonstration here, and also we have to show that f of f inverse is equal to x. So I'm just going to do this first half, and I'll leave the second half. It's pretty much, it comes out pretty easily, just like the first half did. Okay, here's another problem where we want to find an inverse. So again, we're going to replace f of x with y. Let's start with that. And now we're going to switch x and y. And now we're going to solve for y. All right, so I'm going to do this by cross multiplying. So we have x times y plus 2x is equal to 5. Okay, let's isolate the term with y because we want to solve for y. So we're going to subtract 2x from both sides. And now let's solve for y, divide both sides by x. And we have that y is equal to 5 minus 2x over x. And now let's use the f inverse notation instead of y. So finally we have f inverse of x is equal to 5 minus 2x over x. Okay, number 8 is just a fill-in. It says the graph of the inverse function f inverse of x is the reflection of the graph of f of x through the line y equal x. So that's how a function, the graph of a function, is related to the graph of the inverse. In other words, let's say here, let's draw the x and y axes, and I'm going to put a diagonal line here representing the line. This is the line y equal x. It cuts the quadrant in half. So let's say if our function looks like this, if this is f of x, then f inverse of x will look something like that. Okay, these two are symmetric with respect to this dotted line. In other words, if we were to fold this yellow piece of paper along the dotted line, this f inverse would coincide with f.